Good morning, everyone. And as I said, my name is Erik. I represent the ROS Industrial Consortium for the Asia Pacific chapter. I'm from an organization called A-Star ARTC, so it's a pretty long and cryptic name. But we are the Agency for Science, Technology and Research in Singapore. So we develop new technologies to help economic growth and improve lives. Basically, the agency focuses primarily on two clusters of research. We have a pretty big biomedical research group, and then we have a science and engineering cluster, which we are part of. Have about 4,000 researchers today, and also a commercialization arm. So ART stands for the Advanced Remanufacturing and Technology Center. So this is the research institute that the ROS Industrial Consortium is housed. So we primarily focus on advanced manufacturing as well as remanufacturing technologies. And we work with industry partners to create and develop solutions and actually implement them together with industrial partners. So we focus quite a lot on TRLs 4 to 7, bridging the gap from kind of early research and help take that a bit closer to commercialization with some of the companies that we work with. Okay, ARTC has around or almost 300 staff today. We focus on 6 different technological themes related to advanced manufacturing, out of which robotics is one of them. And we have a number of different flagship programs that we're looking at, where ROS Industrial Consortium is one of them. So with that, I'd like to take the opportunity to share some of the activities that we're doing in the consortium within Asia Pacific. I have 2 other sections as well in this presentation, so I'll also cover a few technology showcases and highlights of some of the research and development that is ongoing within the ARTC Research Institute. And then finally, I'll also share some key initiatives that are ongoing within Singapore that relate to ROS and open source robotics. So a few speakers have talked a little bit about ROS growth trend, and I think we've seen a few different trend chart and statistics here before, but I have just a slightly different view of the ROS metrics report that was published by Open Robotics here a few months ago. So I think it's quite amazing how the growth trend is looking at for ROS, and this particular chart is looking at the downloads from unique users. So back in 2016, it was a bit more than 100,000 downloads from unique IP addresses, and I think now we should be nearing towards 500,000 downloads of ROS from different IP addresses, which excludes all the server mirrors that are now available. So I think there are about 10 of them today, including in Asia, China, and so forth. And this statistics doesn't even include all of those downloads. So I think that's quite amazing. Okay, and why are we in Asia, right? So if you look at the users of wiki pages and visitors, you'll find that 8 of the top 20 countries looking at ROS, at least in these statistics, are coming out of Asia, growing around 12% year on year overall. But if you look at certain countries, the growth is pretty fast at this point. So China is growing about 30% year on year. Japan, which has been a pretty conservative market when it comes to open source robotics and ROS, is now growing almost 30% year on year. He's talked about also South Korea the other day. So Korea is growing very fast as well, or I think around 38% year on year. Okay, so membership. So we started a little bit later in Asia Pacific. So the consortium has been operating around 2.5 years now, since middle of 2017. We now have 16 members. We had 6 new members joining in this year. So Konica Minolta was one of them. Omron, Panasonic. SIAA is Industrial Automation Association based in Singapore. So they are an association that have a lot of system integrators part of their membership base and looking at robotics. Singapore Polytechnic is a local school, and then we have Yokogawa joining as well. So you notice there's quite a lot of Japanese MNCs joining the consortium this year, which is also quite interesting. So I'll cover a few highlights on some of the activities that we do, and I think Paul also shared some of the activities in the America side. So some of them are relatively similar. We do similar types of activities and outreach in all the 3 regions. I'll just go very brief here. So we continue to do training for professionals in Asia, and we are, together with the rest of the consortium, looking at extending the training to ROS 2.0 based training. We are also exploring in the future to have more specialized ROS courses or training in, for example, navigation or simulation and other types of more specific topics around ROS. Okay, we're also doing a lot of community and student engagement. So the World ROS-I Day, Move It Day that Paul was talking about. We also have been doing some student outreach so basically to spur interest in the younger generation, to hopefully convince a few of them that robotics is a future market that you should be in. Okay. And one of the key events that we have is this similar conference that we are here with today at Fraunhofer. Is our Asia Pacific workshop that we hold annually each year. So we held it in 18th and 19th of June this year, around summertime, and hosted over 100 attendees out of more than 25 different nationalities. We're also doing more industrial outreach, so we attended some exhibitions, for example, the ITAP exhibition, which is the Asia Pacific version of the Hannover Messe. And we also attended ROSCON Macau together with the global consortium to showcase ROS industrial capabilities and some demos. So in this exhibition, we showcased a number of technologies, including a kind of proof of concept related to augmented reality robotics, as well as how to apply ROS for factory automation and different types of more industrial use cases. We have a couple of ROS packages that we are planning to open source relatively soon. So one of them is the PackML2 solution. So we have Dejanira Arisa in our team has been upgrading the existing PackML solution that has been developed into ROS2, and also been doing some architectural enhancements there using the new, I believe the new lifecycle package in ROS2. So this is something that we're planning to open source quite soon. We also have another package called Robotic Vision Integration Pipeline, or RVIP for short. So this is a package that Gary here, my colleague, has been working on. We want to say hi. So this is a skeleton project that completes a complete pipeline for doing object detection and accurate positioning intended for pick-and-place applications. So if you have interested in this, I'm sure Gary is very happy to talk with you about this and share some more technical details and so forth. So we have some key focus for 2020. So one of them is membership-based. So we're continuing to work with interested companies that are looking for open innovation and collaboration on open source robotics. ROS 2.0, of course, is a key theme here for all of us, I think. So the development projects that we are now starting and have in pipeline are primarily based on ROS 2.0. We're also looking at the software qualification piece of this, on how we ensure robustness in testing and maintainability over time. And third, we're also looking at some key technology components. So we have a few focus areas for the team that we are looking at. So perception and manipulation is one of these areas, or two of these areas that we use for traditionally for pick and place and other types of industrial applications. Another area of focus is navigation. So we have a sister research institute as part of the agency that is looking into research for navigation. And fourth but not least, we are focusing quite a lot on interoperability for robotics. So as robotics adoption is starting to grow, and there's a larger need for robots in various kind of environments, there's also a growing pain and ache of different types of robots, mobile robots and work cells not really interoperating very well with each other. Okay. So I'm not sure how many of you have seen two mobile robots, for example, try to meet each other in a hallway and see what happens. Okay, so this is an area that we're quite interested in, and this I'll be sharing a bit more about this here later on in the presentation as well. And finally, I'll take the opportunity to do some marketing here. So our upcoming Asia Pacific workshop will be held 20 to 21st of May this year, or 2020 coming up. It will be held at ARTC here in Singapore. So the registration is already out. So if you're interested in this, you can just scan the QR code. We have the event out on rosindustrial.org as well. And we now have an early bird promotion still available. So take the opportunity. And happy to see some of you in Singapore here in May. Okay, so with that, I'll go through a couple of technology and application highlights that are some of the focus areas that we're looking at within the Advanced Remanufacturing and Technology Center. So some of these solutions are things that the ROS team is looking at. Some of these things are technologies that our sister teams are working on as well. So we have a number of robotics teams within ARTC. So the first topic area that I'd like to talk a little bit about is simplified robotics, or basically how do we move the needle to increase adoption substantially on various deployments. So one way to do this is to look at reducing the technology barrier from requiring an engineer to be able to implement a solution, down to having the operator being able to do this themselves. Okay, so one solution that we have here is basically a model-based teaching or sequential instructional-based teaching with using simplified GUI tools to allow you to easily create sequences of instructions to perform certain tasks. In this particular demo, we're looking at a gearbox assembly, which requires very precise positioning of some of the mating parts. And we're using ROS for a couple of the parts of this solution. So some of it's proprietary developed. We're using MoveIt and KUKA Robot Driver for this. So this is what this solution looks like. So you have a work cell here in the upper left, which is a cobot station for gearbox assembly. We're using some machine learning and automatic detection of the assembly parts here on a tray. And we have a GUI for easily programming how to create this assembly. And eventually we have the actual assembly using MoveIt and collision-free motion planning. So this is a short video of how this would look like. So you can see here, so you need to import these parts using 3D models in order to create this assembly. But once you have that, you can easily, using click measures, actually create instructions on which parts should be mated to where and using what kind of instruction. This also allows you to kind of tune some of the parameters here. So I mentioned the mating is very particular. So you also have some parameter settings which you can tune here so that you can kind of tweak this and optimize this very easily. Okay, so I'll move on here. So another technology showcase that we are currently working on that is related to the same area is the augmented reality teaching concept, where we are using a Microsoft HoloLens augmented reality headset to connect it to ROS and to perform certain tasks in a more easily manner using hand gestures. So we developed a ROS module that bridged the communication to Microsoft HoloLens kit, and we also developed a Microsoft HoloLens application that allows you to communicate with this bridge to coordinate the information that is required, because you have a work cell with a certain wall reference, and you also have the Microsoft HoloLens which is moving in space. So there's a certain degree of calibration that needs to take place in order for these two subsystems to operate and for the world to be synchronized. So this is what it would look like. So on the left here, you will soon see the view from within the Microsoft HoloLens. And you have a work cell here with some object on it, which is actually dynamic. So the objects here are not really pre-trained, so they're dynamically located and using the user interface in the HoloLens, you can now automatically instruct it to do certain tasks. This is, of course, a technology showcase, but you could imagine that you could extend this into an application where you teach it one time to perform a certain task, or maybe to move it to a certain type of tray in a certain location. And then eventually, after that's done, you can now have the robot perform this task autonomously. The good thing with this solution as compared to the other one is that this actually interacts not only with the robot, it actually interacts with your whole environment and your production line. So you can actually do this instruction on the production line with the actual equipment that is there on location. Some of the limitations related to this is probably accuracy, because the HoloLens and so forth is not so accurate in terms of positioning. The second topic that I'd like to cover a little bit here is some process applications. So we're doing quite a lot of projects. I think we're back online. Okay. So we're doing quite a lot of projects together with end customers to look at specific process applications, and we're looking at providing more flexibility and dynamic solutions for high-mix applications. So for this particular solution, we have a solution related to automatic toolpath generation. Some of you may be familiar with the ROS Scan and Plan solution that is looking at toolpath generation. So this is a slightly different solution. It's using ROS for some of the components. It's using proprietary components for some of the other parts here. There's some differences also in the specific support that this solution has. So this solution is looking at outlining support and also has support for dynamically excluding certain features that you want to exclude from the process. So I think the video later on will show how that works. Okay, and of course this could potentially be applied in a lot of different types of post-processing or applications or surface polishing applications. That we just talked about. Okay, so in the last part of my presentation, I'll talk a bit more about what's happening in Singapore related to ROS and open source robotics. So there's some project initiatives taking place there. Some of them we are involved in, some of them we are not involved in, but I thought it would be quite interesting to share because it's of more general interest. So as you're aware, we are all familiar with ROS and ROS industrial packages, and we all probably agree on that it's very well suited for different types of industrial robot applications, collaborative robot applications, mobile robot applications, and so forth. And I think there's been quite a lot of talks also here on the first day related to integration with Industry 4.0 technologies and so forth. And the next logical step really here for ROS and robotics is to be more connected into enterprise-grade systems, Industry 4.0 solutions, Opus UA, MES, and all those kind of things. So there's a project in Singapore called the Robotics Middleware Framework Project, or RMF for short. This is a project for the healthcare industry, so not really for industrial use. This is a funded by the Singapore government for all the hospitals in Singapore. And the interesting part of this project is that this is a project that is adopting ROS 2.0 and DDS for communication. That is a middleware that basically connects to enterprise hospital IT systems, but it also provides interoperability between different types of robots, both work cells as well as mobile robots, and edge devices, building infrastructure, and so forth, to create a fully interoperable environment where different vendors, fleets of mobile robots, and robotic systems can interoperate. So it also includes different types of tasks, task and fleet scheduling as part of this into one coherent system. And this project will, or many parts of this project will actually be open sourced, or has already been partly open sourced, which I think is great. Okay, so there's a number of organizations taking part in this project. So many of them are Singapore government-related agencies and healthcare-oriented teams, but there's also a couple of private collaborators in this project. So Hope Technic is one of them. They're a local Singapore robotics company, as well as Open Robotics that you're all familiar with. So Open Robotics now has a subsidiary in Singapore. So the reason why Singapore is looking at this really is because today, when you look at the hospital, it's a pretty large, of course, a very large building and environment. You have a lot of floors, you have a lot of systems. You also have cybersecurity to take care of because you have data privacy when it comes to personal records and so forth. And they found that in Singapore, we do want to adopt robotics at a larger scale. I think workforce is a challenge to find the right skill set and labor. So Singapore is looking at robotics and automation also for healthcare. And there's really a challenge to integrate some of these robots nicely into the existing infrastructure that they have. And other challenges with the hospital is that it's 24/7 kind of mission-critical operations, right? You always, you never close a hospital. You have a very dynamic environment with a lot of laymen walking around in corridors. You also have staff that may not be familiar with robotic products, or they may not be trained to work with robots, cybersecurity concerns, and so forth. So what this project team, led by Open Robotics and others, have come up with is this technology or framework called RMF. So I'm not going to go through all the details here. You can probably read up more in detail later on if you're interested. But essentially what it provides is a number of adapters so that you can connect this to more enterprise-grade IT systems, data protocols, so that you can convert your data into essentially ROS-based messages. The other part that it provides is that it provides communication adapters to your mobile robots or your mobile robot fleet manager, enterprise infrastructure, lift, store access, and so forth, as well as to fixed work cells. And within the core, you have a piece of technology there that basically looks at task scheduling, prioritization, planning of all these different tasks that the IT system will instruct RMF to conduct. So some of these packages have been made open source on GitHub, so you can probably check them out. Just a word of caution, this project is still in development. Some of the packages are definitely work in progress, and there's not much documentation yet, but feel free to refer to this. So I'll show a video that has been that was gracefully given to by Open Robotics in Singapore that showcase how this actually looks like when you run this. So this is a gazebo simulation, and this basically shows how RMF has been instructed by the IT system to deliver food or a coffee to a certain ward. Okay. And so the coffee machine here is an example of a fixed work cell, and then of course you have a fleet manager here with a Sesto robot that is scheduled to deliver this coffee task. So quite a large part of this project also relates to asset generation and large-scale simulation testing of these operations. And I'm sure that Stephen also, if you have questions about this and the simulation piece, I'm sure that Stephen is very happy to answer questions as well. Right. Okay. And I think it's pretty much done, so now it's going back to his resting point. Okay, so the final piece here before I conclude is, so why we think this is very interesting. So one is a pretty interesting project from a Singapore perspective. There's actually a second project that has just been granted. So this will be a collaboration between us at ARTC and ROS Industrial Consortium Asia Pacific, as well as Open Robotics, which is also funded by the Singapore government, where we will look at taking this RMF framework that has been specifically catered for the healthcare industry. We are now looking at how we can extend and build upon this to generalize the solution to be applicable for other sectors, basically different types of commercial sectors and applications, and even for industrial use, warehouses and so forth. Because we do talk to quite a lot of end users, and a lot of larger end users actually come to us and have a lot of, they do have a pain point and a need to be able to use different vendors' robots and allow them to interoperate very nicely and seamlessly within their different parts of their organization. And also the second phase project will also have components in there that will be open sourced as well, that will be made public and available. So we're very excited about this. We think interoperability will be a growing issue going forward as robots are more aggressively deployed into different parts of operations, and we do think that this will help to scale up large-scale operations by larger end users. So that's all I had today. So thank you from myself as well as the ROS-I Asia Pacific team.